Hey guys, and welcome to this video. In this video, we're going to talk about Unit 7, probability. 7.1, experimental probability. First, you need to understand what's the meaning of experimental probability and what's the difference between it and between experimental and theoretical probability. Experimental probability means you have an experiment to do. It means it's not fair. It doesn't give you like fair uh, probabilities between the outcomes. That's the meaning of experimental probability. But with theoretical probability, it means it's in theory, it means it is fair. So you have the same probability for all outcomes. So let's take a look at some questions here. These questions are easy. For example, the tally chart shows the colors of flowers that grew from a mixed packet of seeds. Copy and complete the table. So here, red ones have how many? These are 5, 5, so 12. So you write 12 here. And this one's 7. It means you put 7 lines like this. And then the white ones will be 6, so you write 6. This is how you fill the gaps in tally chart. How would you describe each of these probabilities? Now, describing probabilities will use words. For example, let's talk about this, for example, zero point 0.5. 0.5, it means it's half. So half means what? It means using these words, اللي هي impossible, unlikely, even chance, likely, and certain. Half means even chance. Half means even chance. Less than half, which is zero point 0.4, we say it's unlikely. So this one is less than half. So we say unlikely. And then zero point 0.5, which is half, we say even chances. And 60% is more than 5, so it is likely. 60% more than 5, it's likely. And 0% is what? It's impossible. 0% is impossible. Okay? See, 0% is impossible. See this? And then the one that it's certain, 19 over 20 is almost certain. Yes, it's almost certain. So we can say it's certain. And here 1 over 50, 0 is impossible. 1 over 50, we can say it is unlikely. It is unlikely, okay? Now let's see this. Now, let's move on to the next question. As we said, experimental probability, it means it is an experiment. And to find the experimental probability or the relative frequency, which is considered the same, we just divide the frequency over the total frequencies. For example, this is a worked example. Andrew dropped a wrong pin lots of times. It could fall point up or down. So point up, it fell point up 83 times and point down 17 times. So the total frequencies, we add them together, we get 100. And the experimental probability, so we divide the frequency of each one of them over the total. So this one's going to be 83 over 100 and 17 over 100. So this is the experimental probability of point up and the experimental probability of point down. Now let's move on. Let's take a look at this question here. A hospital tried out a new kind of knee surgery on some patients. After 2 years, patients were asked how they felt. The results are shown in the frequency table. So here, these are the results. Let me take this. Yeah. So first thing, copy the table, work out the total frequency. So first, we count the total frequency by adding all of these. So 60 plus 20 is going to be 80. So this one is 80. Now this is the total frequency. Okay. Now after finding the total frequency, the question B will say calculate the experimental probability. So find the experimental probability. We said we find the experimental probability by dividing the frequency over the total frequency. So this one is going to be 60 over 80. So here we write 60 over 80. This is the experimental probability. Let's make it smaller. Here, 15 over 80. So 15 over 80. And here we have 5 over 80. 5 over 80. And this is how you find the experimental probability of each one of them. So first we find the total and then the experimental probability. The hospital claims that patients undergoing the new surgery are very likely to improve. Comment on this claim. So they're saying it's more likely that patients are improving. So here, the outcome, here, no symptoms or symptoms free, 60%, 60 out of 80. Some improvement, 15 out of 80, and no improvement, 5 over 80. So, yes, let me remove this first. Yes. So, what do you think about this? Are they showing, undergoing the surgery, are they very likely to improve? Yes, you can say these are have some improvements here and here, symptoms free, so they improved very well. Okay. So they improved very well. Yes. So it means, yes, it's more likely that they are or very likely to improve. Now let's move on to the next question. Here, same idea. Frequencies. You find the total frequency, and then use it to find the experimental probability of each one of them. Same idea, same questions, okay? And then you can use them to answer the questions. Let's take one of the other questions. All of them have the same ideas. Find the total and then find the experimental probability and then use it to answer the questions. Let's use this table. Yeah, some questions will come like this. So here, a skateboard manufacturer gave 100 customers a set of newly designed wheels to try out. The table shows how long the wheels performed well for the time, which is months. And this is the frequency, how many times it performed well, and the experimental probability after finding the total. So first thing we do, copy the table, work out the experimental probabilities. So first we already know the total, which is 100, and it comes from adding all of these. Now, to find the experimental probability of for the different times for which the wheels performed well, write your answer as a percentage. So first, let's find the experimental probability. This one is 7 over 100. 7 over 100. And when you write it as a percentage, it's going to be what? Very good, 7%. 7%. And how do you turn fractions into percentages? Very good, by multiplying by 100. Multiplying by 100, okay? Now, next one here. Here we have 14. So it's going to be 14 over 100. 14 over 100. And the percentage will be 14%. 14%. Here we have 35. So 35 over 100. And the percentage, 35%. And then we have 25. So 25 over 100. And the percentage, 25%. And then we have 15. So 15 over 100. And the percentage, 15%. And then 3, which is 3 over 100, and the percentage 3%. As we said, to find the percentage, we just multiply the fraction by 100. So this one is 1 over 100, and the percentage is 100%. Okay? And this is how you find the experimental probability and turning it into percentages. Now, estimate the percentage probability that the wheels will have. A second, yes. Okay, let's move this. So, estimate the percentage probability that the wheels will perform well for longer than 8 months. For longer than 8 months. It means longer than 8 months. So, it's not 8 months. We don't count the 8 months. We count the ones longer. So, we count this 9 months, 10 months, and 11 months. So, we take the probability, experimental probability, and we add them together. So 15 plus 3 is going to be 18. 18 plus 1, okay, is going to be 19. So 19 over 100. So we say 19 over 100. And as a percentage, it's going to be 19%. 19%. And why did we say 19? Because we added these three together. We didn't count the 8 months because they said longer than 8 months. Longer than 8 months. Now, why do you think the wheels performed well for different amounts of time? It depends on designing, maybe, and this depends on the model and the design. But these questions are not for you guys. It's okay. All the math questions are important, but these questions are not. The reasoning questions are not important for you. Now, when you repeat an experiment, will you get the same results? Of course not. When you repeat an experiment, you'll have some different results. Okay, so because it depends on the experiment itself. It's not a fixed or theoretical probability. It's an experimental one. Now let's move on to the next question. Here, same idea here. The more times an experiment is repeated, the more reliable is the estimated probability. Yes, the more reliable the probability will be. Yes. Okay, same idea for all of these. You find the total and then you find the experimental probability. Now we're gonna estimate probability or estimating probability. Well, page or lesson 7.2, estimating probability. Let's take a look at estimating probability questions. Working out, these are questions that we talked about before in the past units. When you multiply the 1 over 4 by 60. You do this by simplifying. You can use simplifying method. You can use a calculator because it's allowed. Now divide 4, it's going to give me 1. And divide 4 is going to give me 15. So the final answer is 15. 15 times 1 over 1 is going to be 15. Here, same idea. I can divide this by 5. It will give me 1. And divide this by 5. It's going to give me, let me use this. Yes. It's going to give me 40. Okay. Now you multiply 40 by 3. So 40 times 3 will give you 120. 120. Okay. Again, let me say that. So here, after dividing, yes, after dividing, divide by 5, I'll get 1. And divide by 5, I'll get 40. Now 3 times 40 will give me 120. Same idea with all of them. You have to know how to solve or simplify and then multiply, okay? Now, question 2 here, convert these fractions to percentages. As we said, to convert any fraction to percentage, you just multiply it by 100. You just multiply it by 100. So here, I'm going to multiply this by 100 and then use the simplifying method. Yeah, I can do it with a calculator, of course. So here, 100 will be divided by this. So the end result will be 37. Okay, so 100 is simplified with 100, and the final answer is 37%. 37%. Same idea here. I'm going to multiply by 100. Multiply by 100. Now I'm going to simplify. Simplifying by removing the zeros together. That's the first thing. Now divide by 2. Divide by 2 is going to be 2. Divide by 2 here. Divide by 2 here is going to be 5. You can do the whole thing with a calculator. I'm just showing you the steps, okay? Now 18 divided 2 is going to be 9 times 5 equals 45. Equals 45. And the last one, same idea. You just multiply it by 100. You can use a calculator or the simplifying method. So here the 0 goes with the 0. Now I divide by 5. Divide by 5. Divide by 5. So divide by 5. 25 by 5 is 5. 10 divided 5 is going to be 2. Okay. Now I multiply these 2 times 38 and then divide it by 5. Okay. Yes. So 2 times 8 divide 5. You can use a calculator here. You're allowed to use it in year 8. So 2 times 38 divide 5. It's going to be 15.2. So the final answer is 15.2%, like this. Don't forget the percent sign, even here. And this is how I answer a question like this. Now let's move on to the next question. Here, as we said, we talked about experimental probability. Same idea here, but we call it relative frequency. Relative frequency. The relative frequency is the same in which, for example, here smartphones are 10, tablets are 18, computers are 22. Now, when you add them together to get the total number, you'll get 50. And then to find the relative frequency of each one of them, you take the frequency and divide it by the total frequencies. So take the frequency divided by the total frequencies. Take the frequency divided by total frequencies. We call this relative frequency. Call it relative frequency. And then you can use it to find the expected frequency. To find the expected frequency, you multiply the relative frequency by the number of times something happened. Now, let's take a question and you'll understand it more. Let's talk about this question, for example, here. Restaurant owner Maurice recorded the number of seats reserved for each booking during a week. During a week. Now, focus on this because it's very important. Copy and complete the table. So the first thing we need to do is find the total frequencies, and we do this by adding all of these together. So 30, 40, 50, 60, 70, 80. So the total is 80. Now, we're going to use the total and the frequencies to find the relative frequencies. So the first one is 30 over 80. 30 over 80. So we write it like this, 30 over 80. Let's make it smaller. Yes. Second relative frequency is 10 over 80. 10 over 80. And then we have 25 over 80. And then 5 over 80. And then 10 over 80. We call these the relative frequencies. So basically, you find the total frequency, and then you divide or put the frequency over the total frequencies. Now, after finding the relative frequency, as we said, now we're going to use it to solve the questions. Question B, estimate the probability that the next booking will be for 2 seats. So we find the probability that the next booking will be for 2 seats. Now, when we look at the table, the 2 seats are over here. These are the 2 seats. And the probability of having 2 seats is 30 over 80. 30 over 80. Now, when you have it as a fraction, let's write it here, you have to simplify it more. So it's going to be 30 over 80. To simplify it, I can use the calculator like this. The calculator will remove the zeros together, and the final probability will be 3 over 8. So equals 3 over 8. And this is the probability of having 2 seats. Now let's move on to the next question. Question C. Maurice says that it is unlikely that a booking will be for less than 4 people. Is he correct? Explain how you know. So he said it is unlikely the booking will be for less than 4 people. So we take a look at the table. Let's remove this first. Let's remove it. So we find the probabilities for the number of people which are less than 4. So we have the 3 and the 2. 3 and 2. Now we look at the probabilities. We add them together. So 30 and 10. So we have 30 and 10 like this. Let's write it here. 30 plus 10 equals 40. And then the 40 will be over the total, which is 80. Now, 40 over 80 as a probability. What is the word that describes 40 over 80? Very good. 40 over 80, when you divide it, it will give you 0 0.5 or 1 over 2. Let's write it as a fraction. 1 over 2. Now, 1 over 2 is what? Very good. It's an even chance. Even chance. or a 50-50 chance, or we call it even chance. So it means what? It means that he is wrong. It's not unlikely, it is even. It is even chance. Okay. And how did we find this? By finding the probabilities of these seats which are less than 4. We added them together, we got 40 over 80. So this means that the probability is an even chance probability. Now let's move on to the next question. Here, the restaurant has approximately 240 bookings each month. How many of these would you expect to be for 4 seats? So now we're talking about 4 seats bookings. Let's remove this. First, let's find the probability of, or the experimental, or the relative frequency of the 4 seats. This is the 4 seats. The relative frequency is 25 over 80. Now we take the relative frequency and multiply it by the number of times, which is 240. So we're going to take 25 over 80, like this. This is the relative frequency of 4 seats. Now we multiply it by the number of times, which is 240, times 240. Now we start simplifying. First step, we can remove the zeros together, this 0 and this 0. Now we start simplifying by dividing. Divide 8 is going to give me 1, and divide 8 is going to give me 3. So let's write it here. When you divide 8, it's going to give you 1. Divide this by 8, it's going to give you 3, because 3 times 8 is 24. Now, we have 25 times 3, which will equal what? Good. So 25 times 3, it will give me, very good, 75. And this is the answer of question D. Now, that's the idea for question 5. I hope you understood the ideas of relative frequencies. Now, relative frequencies are almost, or they're considered the same as the experimental probabilities, and we can use them to find the expected probability of an event. Okay. Yes. And the 3 came from dividing. I'll do it again here, from simplifying. So I divided the 8 by 8 and divided the 24 by 8. 8 divide 8 will give me 1, and 24 divide 8 will give me 3. And then I multiplied the 3 by the 25, and I got 75. And that's the idea of answering a question like this. Now let's move on to the next question. Yeah. Now we understand the idea of relative frequencies and experimental probabilities and expected probability. Same idea here. You can find the total frequencies, use them to find the relative frequency, and then use them to answer the question. Same idea with all questions in this page. And this is the idea of Unit 7. I hope you understood all the ideas. Thank you very much for watching. See you next time.